The concept of sustainable development was applied to the design of the Ministry of Public Works offices and grounds by building in a high-density area, including wider green open spaces, restricting the movement of vehicles on site, interconnecting pedestrian paths, and integrating mechanical, electrical, and plumbing systems on site as well. Based on a recent study, the number of Ministry of Public Works staff will continue to rise, and thus more space will be required. Vertical construction based on sustainable development is thus the most appropriate solution for future construction plans for the Ministry of Public Works. Vertical planning will also widen the area of green open space. With more trees, the ground's microclimate will be improved. 100 trees can absorb 8 tons of carbon dioxide per year. One tree absorbs 75% of dust particles. Half a hectare of green open space can hold runoff from rain and soak water into the ground as much as 10,219 cubic meters per year. Trees also absorb 80% of solar radiation, which plays a role in evaporation and transpiration. The Ministry of Public Works office and grounds design also applies a zero runoff system by maintaining a rainwater catchment area so that all rainwater that falls on the site can be absorbed into the ground by using infiltration wells. In addition, the Ministry of Public Works design integrates mechanical, electrical, and plumbing systems amongst its buildings on site to be more efficient and effective. These systems include power grids, wastewater, fire extinguisher systems, clean water, security systems, and communication systems. Waste management is conducted in an integrated manner. It is done by separating wet and dry waste, while organic waste is processed using a composter. The Bike to Work program is also promoted by providing bicycle parking and showers on site, while the use of public transportation is also encouraged by providing bus shelters. A green design is applied in the main building through its shape and orientation, building envelope and shading, natural lighting, artificial lighting efficiency, heating, ventilation, and air conditioning system efficiency, integrated vertical transportation, water management, and building materials. Typical energy consumption in office buildings is dominated by the heating, ventilation, and air conditioning system and lighting. Streamlining these two components can significantly reduce energy consumption. At first, the main building design was such that the largest facades were located on the east and west sides, so that the solar radiation exposure was relatively high. The design was thus modified by reducing the sections facing east and west, which were exposed to solar radiation, by adding solid walls, as well as by orienting openings optimally to the north and south sides. The building's thickness was maximized to incorporate more natural lighting indoors. By doing some alternative designs in the form of orientation and building shape improvements, replacement of clear glass with reflective glass, adding insulation to walls, and installation of shading on windows, simulation results of typical floors on the final design show a significant reduction of the solar heat radiation through windows, overall thermal transfer values, and in the end, reduction of the cooling load. Solar heat radiation incoming into the rooms, which was originally at 684 kilowatts, dropped precipitously to 83 kilowatts, so as to reduce overall thermal transfer values, which were originally 76 watts per square meter, to 28 watts per square meter, and further streamlined the cooling load from 53.5 tons of refrigeration to 34.5 tons of refrigeration. Light shelves were added to maximize the solar light reflecting into rooms by distributing this natural lighting so that it could reflect the farthest reaches of the rooms. The combination of the room's short depth designs and light shelves has resulted in 2/3 of a room enjoying natural lighting as per the requirement of 300 lux. The use of transparent interior partitions also promotes better distribution of natural lighting into the rooms. By using an automatic control system such as lighting sensors, setting light times, motion sensors, and generally prioritizing natural lighting over artificial lighting, reduced the energy consumption from lamps from 722 kilowatts originally to 348 kilowatts. Furthermore, promoting stairs for vertical circulation access to reach adjacent floors in the Ministry of Public Works buildings helped to reduce the burden of electric energy use required by elevators. Water from air conditioning condensation, used ablution water, and rainwater are reused for toilet flushing, gardening, and cooling water makeup. The sustainability of the materials selected was maximized by opting for low-energy, environmentally friendly, toxic-free, and ISO 14011 certified materials. To summarize, the thermal performance of the building envelope, or its overall thermal transfer value, was reduced from 76 watts per square meter to 28 watts per square meter with the new design. This value is well below the maximum limit regulated by the DKI government, which is 45 watts per square meter. Energy consumption per year may also be reduced to 140 kilowatts per square meter per year, when compared with common practice in Jakarta, which is 250 kilowatts per square meter per year, thus obtaining a saving of 44%, or equivalent by reducing carbon emissions by 1,880 tons per year. This is equivalent to carbon dioxide absorbed by 165 banyan trees. Finally, water resource savings reached 83% if we account for rainwater and 61% without rainwater.